today is the 21st. And this was our last lecture. I'll get to this in a minute. Okay, so we're looking at problem 40 on page 395. And this is the integral from 1 to 2 from 4 plus u squared over u cubed du. Perfect example. We don't know how to integrate a fraction, but this fraction happens to have one term in the denominator. So what I will do is the integral from 1 to 2 from 4 over u cubed plus u squared over u cubed du. I'm allowed to do that as long as the denominator is just one term. Now I will simplify. I will replace 4 over u cubed by 4 times u to negative 3. And then plus 1 over u, which I will not change because I know exactly what that means. So now I need to find the antiderivative of 4u to negative 3. What is the antiderivative of 4 times u to negative 3? So it's 4 u to negative 3 plus 1 over negative 3 plus 1 plus, what is the antiderivative of 1 over u? Of the absolute value of u. Or x in this case, but it's u. Very good. And all this from 1 to 2. So now this is negative 2. 4 over negative 2 is negative 2. And u to negative 2 plus natural log of u from 1 to 2. Is this okay so far? Okay, ready? Now, I plug in everywhere 2, and then subtract when I plug in everywhere 1. When I plug in 2, I have negative 2, 1 over 4, plus natural log 2, minus, put parentheses so you don't mess up the signs. When I plug in 1 is negative 2, when I plug in 1 is 0. So this is negative 1/2 plus natural log 2 and plus 2. And 2 times 2 is 4, 4 minus 1 is 3. So natural log 2 minus 3/2. Is this clear? All steps? All steps? As I think I told you, I was at a conference this weekend, and one of the professors presented 3D printing. So she printed this solid using math, of course, and this is a half a sphere and this is a cone. And I held it in my hand. Now I went next door where our people are working right here, in literally the next room. And he was just printing right now, a few minutes ago, a few things that he's working on. And here's one that he printed. It takes hours to print this. It's not done with paper. There is a real wheel with thread, and that thread is fed into a little machine that goes micron by micron, not even inch by inch, and creates this.
So I guess that's Mega Man, or?
I have no idea, but this is just
It
this.
looks like his head on like just things.
It just became our mascot. So
I think they're new guys in the mom shop.
They
Good.
have a 3D printer in my
They
office.
can 3D print titanium.
Yeah.
Which is pretty cool.
good. Okay. Any questions on this problem? Four minus. It's plus here. 4 minus 1, 3/2. Sorry. Any questions? Is there anything else you would like to go back to? Anything else that you'd like to see before I choose problems?
I'm practicing all week.
Okay. So the next step, if you remember, we have a couple of things left. One is the substitution rule for definite integrals, which we did not look at yet. So now I think it's the time to go through this. This was about a question on how to find xi. This was another question from your book. These were the properties of definite integral. More properties of the definite integral and some examples. Again, if it's the integral from a to a from any function, that's 0. The absolute value, we had to break it up, and then we had two integrals. Then comparison properties of the definite integral. If one function is higher than the other, the integral will be higher, of course. If a function is squeezed between two values, then we have this property. Then we said for an odd function and a symmetric interval, the integral is 0. But for an even function symmetric interval, the integral will be 2 times the integral from 0 to a from f of x dx. And then we looked at some problems with properties of the definite integral. And then we looked at more problems. And oh, that was it. And we looked at more problems. And we looked at more problems. And then the substitution rule is coming up. And we said we have two types of integrals, definite and indefinite. The indefinite is a function, and we can always check the answer. And more problems, the total distance and displacement, and more problems. And then finally the substitution rule for indefinite integrals. And that is it. Good. Anyone interested in this? Yes.
Thank you.
Thank you. Very good. So that's our next step. So I'm hoping that in about roughly an hour we finish everything and then we start reviewing. Okay, so let's look at the substitution rule for definite integrals. Okay, and we are on page, so this is section 5.5, which we did not finish last time. Okay, and the indefinite integrals are between 53 and 73. 53 and 73, and on page 414. So let's choose anything that catches your eye. Which one?
54.
Okay, very good. Let's start with 54. And the integral from 0 to 1. Is this a definite integral or an indefinite integral?
Definite.
Very good, because it has limits of integration. Very good. So I have no way of solving this because I'm not going to raise 3t minus 1 to the 50th power. I hope you agree with me. So then I'm going to say let y, for example, be
3t minus 1.
very good. I have to have dy in the problem. How much is dy?
3
3.
dt.
Very good. I don't have 3 dt. I have dt, but that's not a problem. Here's what I do. Multiply by 3 and divide by 3, which means 1. I'm not changing anything. But let's see what we have. Because once I change this, it has to be fully changed into a definite integral with y instead of t. So 1/3 is outside. Do not copy the limits of integration. And what do I have inside? Can anyone dictate the inside?
U to the 50th.
U to the 50th or y to the 50th?
Oh, sorry. Y to the 50th.
And
dy.
very good. Now, the limits of integration from t cannot be copied as the limits of integration for y. I have to plug it in. When I plug in 0 for t, what is the lower limit for y? How much?
-1.
Perfect. When I plug in 1, what is the upper limit for y? 2. And when it comes to a definite integral, I do not need to go back and replace anything, because the answer will be a number. So, what function prime is u to the 50th? Y to the 50th.
Want to live in the 51st or 51st.
Okay, and then from -1 to 2. Please leave the constant outside, don't mess with it. So it's 1 over 153. I multiplied 3 by 51. And then when I plug in 2, I have 2 raised to the 51st power and minus 1 to the 51st power, which is 1. So the answer is 2 to 51st minus 1 divided by 153. I can plug it in the calculator and see what I get. So let's do 2. Well, I know 2 to the 10th what it is, but 2 to the 51st, I should leave it as is, I think. 2 raised to the 51st power. Ooh.
Should be a pretty big number.
2.2 times e to the 15th power. I wouldn't mess with it. Leave it as is. Very good. Let's say problem 59. In 59, we have the integral from 1 to 2 from e raised to 1 over x over x squared dx. What do you think? We need a substitution. What bothers you? I know this is not a mathematical way of thinking about the substitution.
1 over x.
Yes, that bothers me, doesn't it? Bother you? Okay. So then, what do you think I should denote, let's say, y by?
1 over x.
Good. As long as dy is in the problem, I'm fine. Or just a constant is missing or needs to be adjusted, that's fine. So how much is 1 over x? What is a differential of 1 over x? Negative,
-1 over x.
right? So -1 over x squared dx. So there is only one little adjustment that I have to make. Here it is. And then how much is this? dy. So then, negative outside. And what is left inside? Do not copy the limits of integration.
E to the u du.
Very good.
E to the y.
Yes, e to the y dy. The limits of integration are for x. I cannot copy them as being for y. So let's plug in 1. What do we get? Good. Let's plug in 2. What do we get? Good. Good. What function prime is e to y?
dy. dy.
So negative e to y from 1 to 1/2. Leave the negative outside. E to 1/2 minus e. But this is the same with e minus the square root of e. I distributed the negative sign.
Could you move up a little bit?
Yes. Oh, I'm sorry.
No, you're fine.
Notice that we do not go back to the original variable. There is no need because we changed the limits of integration. Forget about the first variable, which is not the case when we differentiate indefinite integrals. The answer is a function and it has to be given in the original variable. Very good. Yes, let's look at 62. From 0 to pi over 2, cosine x multiplied by sine of sine x dx. So again, I'm going to say this is not the mathematical way of thinking, but it definitely is helping. I'm going to ask what bothers you. And you will say,
Sine x.
right, why sine x bothers me? Because it's inside another function. I don't like that. I don't want that. So I'm going to say let y be sine x. As long as dy is in the problem. Because I cannot make up a function, but I can make up numbers, factors. So dy equals cosine dx. And here it is. That's my dy. It's in the problem. So do not copy the limits of integration. But what is inside?
Well, sine y dy.
Very good. Now the limits of integration. Please plug in 0.
0.
Sine, yes, sine is 0. Please plug in pi over 2.
It's 1.
1. Therefore, which function prime is sine y?
Cosine of y evaluated from 1 to 0.
Negative.
Sine. Oh, yeah.
No problem. From 0 to 1. 1 means 1 radian now, and 0 means 0 radians. Okay, so then what do I write? Leave the negative outside for a moment. So it's negative cosine 1 minus cosine 0. Nobody needs to determine this because it's cosine 57 degrees. Nobody knows what that is. But how much is cosine 0? Yes, because it's measured on the x-axis. So this will be cosine 1 minus 1, and I'll distribute. 1 minus cosine 1. (66). The integral from negative pi over 3 to pi over 3 from x to the 4th sine x dx. Any suggestions here? Any ideas? Any suggestions? Anything?
Let's let y equal to x squared. Or no?
Any suggestions? Okay, here's my first hint. Once I notice that the interval is symmetric, what do I have to find?
Okay. Well, since the interval is symmetric, then you just have 2 times the interval from 0 to power.
No. So once I establish that the interval is symmetric, in the second step I have to establish one thing, whether the function is exactly. So the function is x to the fourth sine x. I have to find f of negative x. Negative x to the fourth sine negative x. How much is negative x to the fourth? To the fourth. What about sine of negative x? Is sine an odd function? If it's odd, then it's negative sine x. If it's even, then it's sine x. There are only, out of 6 trigonometric functions, only 2 of them are even. Everything else is odd.
The sine spits out, so it's negative sine x.
Yes. The 2 even functions are cosine and the function that has only cosine in it. What is the function that has only cosine in it? Yes, there is one trig function that has only cosine in it and nothing else. And that function is?
1 minus.
Exactly. Only cosine and secant are even functions. Everything else is odd. Sine is odd, tangent is odd, cotangent is odd, and cosecant is odd. So therefore, this is negative sine x, which makes it negative x to the fourth sine x. Therefore, this function is the same with negative f of x, which means the function is, if it's f of negative x equals negative f of x, then the function is
Well, f of negative x.
So odd.
exactly. If the function is odd and the interval is symmetric, the answer is, it's in your notes. It's right there in your notes.
0.
Exactly. Exactly. If the interval is symmetric and the function is odd, the answer is 0. Good. Let's look at 69. I said 69, I wrote 68. Okay. The integral from e to the fourth dx over x, the square root of natural log x. Let's work on this problem for 2 minutes or 1 minute. Can anyone give us a hint so we are all on the same page?
Well, you start with the with setting y equal to the natural log of x, and then dy is equal to dx over x.
Exactly. Or 1 over x dx, or dx over x. Good. Excellent. Do not copy the limits of integration. Remember, you have a new function. You're using a different variable if you want to call it a variable. So the limits of integration must be different. Can anyone just tell me the new integral?
Du.
Yes, or dy
Sorry,
doesn't
dy.
matter. You can use u, it's the same thing.
Sorry, dy over x.
Over the square root
Oh,
of y, sorry.
Good. So now when I plug in e, what do I get? 1. When I plug in e to the fourth, what do I get? Do you all agree with this? Now we have to change 1 over the square root of y into
Y to the negative 1/2.
y to negative 1/2 dy. Good, very good. So therefore, y to negative 1/2 plus 1 is y to 1/2 over 1/2 from 1 to 4. I have to flip 1/2, so it's 2. Leave it alone. The square root of y from 1 to 4. 2, I plug in 4, I get 2. Minus, I plug in 1, I get 1. So it is 2. Any questions on this? Any questions? Okay, let's move on.
I think I might need a little bit more help with detecting the symmetric intervals.
Yes.
Because you know, sine really is symmetric about the y-axis. So when you kind
Sine is not symmetric about the y-axis. Sine is symmetric about the origin. It's an odd function.
Okay. But I just kind of needed a way just to be able to look at an interval and just.
Whenever you see, it's a very good point you're making. Whenever you see a symmetric interval, you have to go that route first. Every time the interval is symmetric, you have to check whether the function is odd or even.
Whether it's multiplied by a trig function or not, or
It doesn't matter. You plug in the entire function, you plug in negative x, and you see what you get.
okay.
Yes?
So we have another example of finding d of y. So like we get the y, then we differentiate the y, and I don't get how we're getting to the second part, which is
Let's take a look. Which one? You
okay,
mean from
so
here,
the first
here?
one, yes, the first one you got 1/3 in front of the interval. How did you do that?
Oh, because dy was 3 times dx.
So you just divide it to get to the x alone?
No. So so that's the only question you have?
Yeah.
Okay, very good. So let's say I have the integral from let me look at the problem. Let me choose a problem. Like, for example, 63. So the integral from 0 to 15. Why would I invent a problem when I have tons in here? The cube root of 1 plus 2x to the second power. So what do you think we should do here?
Just that y equal to 1 plus 2x.
Yes, so then y equals 1 plus 2x. So then dy equals?
2.
No. I need a differential. This is not y prime. This is dy. So a function, its differential is dy equals f prime of x dx. So 2 doesn't make it.
So it's 2d.
2 dx. Is that clear? Okay, so then I don't have the 2. That's fine. Multiply and divide by 2. So 2 over 1 times 1 over 2 is still 1. I didn't change anything. By multiplying by the numerator by 2 and the denominator by 2, I don't change anything. But I know that this is my dy. So 1/2 stays outside because I still have it there. The integral from dy divided by y to 2/3. But I have to change the limits of integration. I can't put the same limits that I had for x, transfer them to y, because that's not true. So when x is 0, how much is y? Good. And when x is 15, y is 31. So now this is, are you okay with this now? Better? Okay. So then this is 1/2 the integral from y to negative 2/3 dy from -1 to 31. So this is 1/2 y to 32 over 32 from -1 to 31. Leave the constant outside. The constant is 1 over 64. Do not mess with it because it becomes difficult. So I plug in 31. So
This was a positive one.
31 to the 32 minus 1.
so what did I, what, and nobody said anything. I'm asleep at the wheel. And nobody said anything. Okay, 1/2 y to negative 2/3 plus 1 over negative 2/3 plus 1 from -1 to 31. I just copied something there. Sorry about that. So then 1/2 is outside. Negative 2/3 plus 1 is y to 1/3. The denominator is 1/3, and I flip, of course, from 1 to 31. So I flip 1/3, so this is 3/2, and this is the cube root. Yep, the cube root of y from 1 to 31, which is 3 over 2, the cube root of 31 minus 1. Sorry about that. I don't know why I wrote 32.
You're fine.
I mean, I had no reason to write 32. Okay? Can I choose the next problem? Okay. What about 73? The integral from 0 to 1 dx over 1 plus the square root of x, everything to the 4th power. Let's work on this for 1 minute. Ready? So we'll say let u or y, whatever you want.
1 plus.
Well, that's what bothers me, and there is nothing else, right? So I will say 1 plus the square root of x. Then dy is
1/2 x to the negative 1.
dx. Don't forget dx. And you can say, what do I do now? And here's what I will do now. Since I cannot make the square root of x, I have, when I replace dx, this is dx that I have to replace, and I will multiply both sides by 2 the square root of x, right? So then dx is 2 the square root of x dy, correct? So this will be replaced by 2 the square root of x dy, but I cannot have x and y in the same problem. So what should I do to eliminate this or replace it with something in terms of y? What will you do? What will I do to eliminate? So how much is the square root of x from here?
So
Y minus 1. So then dx is 2 times y minus 1 times dy. So the new integral, do not copy the limits of integration. So let's plug in 0. What do we get for y? 1. Let's plug in 1. What do we get for y? 2. And please tell me what to replace. How do I rewrite all this? The top. 2 quantity y minus 1 dy, and this is just this, everything over, which is much easier because now I can split into 2 fractions and I can take it from there. So let's finish it. Is this okay so far? Okay. So leave the 2 outside. So we have the integral from y over y to the 4th minus 1 over y to the 4th dy from 1 to 2. So I will simplify the integral from 1 to 2. 1 over y to the 3rd, right? Or y to negative 3 minus y to negative 4 dy. Is this clear so far? So now I have 2. Y to negative 3 plus 1, which is y to negative 2 over negative 2. Y to negative 4 plus 1, which is y to negative 3 over negative 3, and 1 to 2. Okay? Rewrite it one more time. Negative 1/2 y to negative 2 plus 1/3 y to negative 3 from 1 to 2. Leave the 2 outside and then distribute it in when you need it. So I plug in 2. So this will be 1 over 4 times 1 over 2, which is negative 1 over 8, plus. So 1 over 8 times 1 over 3, which is 1 over 24. And now minus, parentheses. When I plug in 1, I get 1/2. When I plug in 1, I get 1/3. 2, negative 1 over 8 plus 1 over 24. Sorry, minus 1 over 2 minus 1 over 3. The least common denominator turns out to be 24. So I need a 3, a 1 here, a 12 here, and an 8 here. So negative 3 plus 1 minus 12 minus 8. So that's negative 20, that's negative 23, that's negative 22. So negative 2 times 22 over 24. Negative 11/6. Any questions? Any questions?